going to continue our vector product topic. Yeah. So, in the previous video we have done what? Yes, special cases of vector product. Got it? Yeah. And in this video we are going to do properties of vector product. So, I hope you all have watched the previous video. So, let us start our today's topic. Yeah. So, in today's video we are going to see some following properties of vector product. So, I have already written the first one property. Let us see it. So, vector product doesn't follow commutative law. What does it mean? This means that first of all, let me ask you a question, then we will continue. So, does vector product follow commutative law? Yes or no? No. Actually, vector product doesn't follow commutative law, and that's the statement here is also written. So, but in dot product dot product obeys commutative law, but vector product doesn't obey commutative law. So, let's see through some example. So, let's see through an example. So, I'm only going to take one example. Then we will, then we will go to our second property. That's it. Yeah. So, for example, let's take, we have to prove vector A cross B is equals to vector B cross A. Okay. So, if vector A cross B is equals to vector B cross A, so let us see it. Yeah, so if vector A cross B is equals to vector B cross A, then let me just show you the answer. So, first of all, let me draw the figure. So, figure should be like this. Vector A, vector B, theta, and so A cross B will be what? Here. Through thumb rule, let's see it. So, first of all, A is coming, so A cross B. See, I'm curling my fingers from A to B, and my thumb is pointing in north direction, in upwards. So, this means that A cross B is in up direction, north direction. Okay. So, this is our vector A cross B, or we can say vector C, but we have not mentioned vector C. So, we are only going to write vector A cross vector B. Got it? Yeah. And so, where will be vector B cross A? Think in its opposite. So, first of all, B is coming. So, I am going to curl my fingers from B to A. From B to A, and see, I am curling my fingers from B to A, and my thumb is pointing in south direction. See? Okay. So, but B cross A is pointing in south direction. So, is this will be equal to? Is vector A vector A cross B equal to vector B cross A? No. Why? Let me just tell you that this is not equal to, means the cross product of this vector is not equal to this vector. Got it? Why? Let me tell you. Because their directions are in, means that their directions are different. See? Have you seen it? Yeah. So, their directions are different, but we can say that their magnitude will be same. Their magnitude will be same. Let me just first of all write that. Their magnitudes can be same, but their direction is not. So, their magnitudes can be same, but their directions are not same. So, we can't say that their directions are equal to each other. So, this means that A cross B is not equal to vector B cross vector A. And but we can write that vector A cross B is equal to minus B cross A. Did you see it? What I did? See, actually I have taken the B in negative. So this means that when I put any negative sign, so this only means that what means their direction is in opposite. So let's take that B is in north. So what? Minus B will be in south, means in its opposite direction. Okay, but now let's see through right hand thumb rule. So A cross B same in upwards coming. A cross B, thumb is pointing in north direction, so A cross B will be as it is same. But let's see minus B cross A. Minus B, here is now minus B. Here was B, so I simply put like normally. But here is minus B, then what we are going to do? Yes? I have told you that its direction will be only changed. So B was here, so this means that minus B will be in opposites. So B is here, so this means that B will be in its opposite, so minus B A. So this means that minus B will be in its opposite direction. So when we just curl it, so what it will come? It will also come in upwards direction. In upwards direction. Okay? Got it? See it again. Have you all just got it? How? Minus B will be taken in its opposite direction. So this is how, when we do the cross product of this vector, then we are also, then in this condition also our thumb will point in north direction. And always remember that this vector is in plane. This vector is in plane. Okay? See? Got it? Yeah. So actually this is also in plane. So let me just make it bigger. Yeah, so let's take this one, but it will be too long. So let me write vector B cross A here, vector B cross vector A. So then it will be like this. Got it? Okay, and A cross B is also in the plane. So this means that we can write that what? A cross B is equal to minus B cross A. Always remember that. Okay, so this one is important. Don't forget to write, means don't forget to add minus. And if we don't put just minus, then our answer will be whole. Then our whole answer will be wrong. Got it? So through a single negative sign, means if we do not put a negative, then our whole answer will be going to what? Wrong. It's going to be wrong. So we can say that A cross B is equal to minus B cross A. Okay. So I hope you all have understood the first one property. So never forget to add negative sign. Negative sign. Got it? Yeah. So now we are going to continue. So now let us do second one property. Yeah. Second one property. So wait a second. Let me just check the camera. Okay, so this camera is not blur. Yeah, so let's continue. Let's continue. Now our third one, sorry, our second one property will be what? Let me tell you that. Does vector product follow distributive law? Tell me. Does vector product follow distributive law? Yes or no? Yes. Actually, vector product also follow what? Distributive law. Distributive law. So yes, vector product does follow, or simply we can write obey. No, let me just write does follow. Okay, does follow distributive law. Yeah, so now yes, vector product follow what? Distributive law. So it always obey what? Distributive law. It always obeys distributive law. Yeah, and so always remember that in first property, magnitude can be same, but their directions can't be same. So remember that I'm writing here, their magnitudes will be same but not their direction. Magnitude, let me just write full statement. Yeah, so their magnitudes will be same but their directions will not. Will not be same. Yeah, so their magnitudes will be same but their directions will not be same to each other. Let me just also add to each other. Yeah, so their magnitudes will be same but their directions will not be same to each other. Got it? Yeah, so let's get back to our second property. So yes, vector product does follow what? Distributive law. Yeah, so now let me just take an example. So in the vector product we also need to take examples so that I can prove and you can also see that second property is also correct. Actually first one property we have proved that yes, the statement given to us is correct. So let me just prove you this one also. Got it? So let's take related to distributive law. Means let's take example related to distributive law. Yeah, so let's take vector A cross vector B plus C. Okay, this one is correct. C, vector A cross B plus C. Vector A cross B plus C. So in distributive law we will write it like this. C, vector A cross B plus vector A cross C. Vector A cross B plus vector A cross C. Let me show you how. So vector A, so we are going to do cross product of vector A from first of all B and then from C also. Got it? You can also put them in brackets, but I am not going to do. Yeah, so now let's take some big one. Yeah, so let me take this. This was the first one. Now let me take second one. So what should I take? So I'm going to take this one. Vector A. Yeah, vector A plus B cross. Always remember we have to say it cross, not multiply. And vector C plus vector D. Okay, and so this one will be big. Yeah, so what we are going to do? So first of all, I am going to do the vector product of vector A from C1 and D1. Okay, means I am going to do vector product of vector A first of all with vector C and vector D, and then same one to B, same as it is to B. Yeah, so same as it is for B. Got it? Now I hope you all have understood. Yeah, so yeah, vector A first of all with C. So vector A cross C plus vector A cross G plus vector A. No, vector A is finished. So now we are going to use we are going to put what? Vector B. Yeah, so vector B cross C plus vector B cross vector D. See? So this one is the correct one? Yes or no? Of course yes. So you can see that what? Vector product does follow distributive law. So we have also proved that this property correct. Means this property is correct. So through these examples, we can show anyone that this property is right, 100% correct. Okay, yeah. So now there is one more property that we are going to do, and then we will finish our today's video. Yeah. So let's take third one property. So what will be our third one property? Yeah. So cross product, let me write. Cross product. Don't be confused. This is cross, not gosh. Gosh, not gosh. It is cross. Okay? Not gosh. So let me just write vector. If anyone just get confused, then yeah. So vector product. So this will be clear to you. So yeah, vector product with itself gives a what? Zero. See, read it. What it is? Vector product with itself give a 0. Got it? So this is our third one property. What it is? Vector product, or we can say cross product with itself is 0. So let me just write it more clearly. This one can also be correct, but I'm going to write it by another way. So vector product of vector. So cross product of vector, I'm going to say cross. So cross product of vector with itself is will be. Let me just write will be. Yeah. So vector product of vector with itself will be 0. So let's see, this one is correct. This one will be more perfect than the previous one statement. So vector product of vector with itself will be 0. With itself will be 0. Got it? So what is it saying? It is saying that when we do vector product of vector with itself, then we will get always 0. Let's see how. Got it? Yeah. So let me just tell you how. So let's take vector A. So we are going to do cross of vector A and vector A. Means of vector A. Yeah, I am going to do the cross product of vector A with itself. Means vector product of vector with itself. Vector product of vector with itself will be 0. Let's see how. So it is like cross. So what was the formula for the cross product of two vectors? It was, let's take this one. So it was mod A, mod B, sine theta. So I hope you all have now just means. So I hope you all have know the formula because I have written it many times. Yeah. So let's get back. Yeah, so A cross B is equals to mod A mod B sine theta. I've told you. Yeah, so A cross A. So what it will be the formula? Our formula will be mod A sine theta. This will be an example. Okay. So mod A sine theta. So mod A will be what? What? First of all, let me just tell you what? Yeah. So sine theta. So as I am saying that we are doing cross product of vector with itself. So this means that vector A both are in same direction. So and this is how they are making the angle of 0 degree. So means their theta will be 0 degree. Why? Because they are parallel. And I have told you in a special case, then if our theta is 0, this means that those vectors will be known as, those vectors are called parallel vectors, or we can say like vectors. Why? Because they are going in same direction. So Our theta will be what? 0 degrees. So now mod A, then sine 0. And I have told you that sine 0 degrees equals to 0. So our whole answer will be 0. Our whole answer will be 0. Got it? So as in another vectors, let me just rub hole. Yeah. So vectors. So in another vectors, let's take I cap. So I cap, when we do cross product of I cap with itself, then we are getting 0. And when we do cross product of j cap, first of all let me here j cap. So j cap is equals to 0. So means cross product of j cap with itself will be also 0. And so cross product of vector, not vector, k cap from k cap will be also 0. So this means that all the three orthogonal unit vectors are having answer 0. So this means that when we just do vector product of vector with itself, it will always be 0. Don't forget. It will always be what? 0. Got it? So I hope you all have understood all the three properties of vector product. And so that's all for today. And remember that, and if any question it is given that what if two vectors are parallel vectors, so this means that their theta will be 0 degree. Okay, got it? So we can easily find theta, means we can easily find through what hint that what will be a theta. Got it? Yeah. So have a great day.